Okay, guys, this lesson is on rational functions. A rational function is written as f of x, just like a regular function. That's how we say it, f of x. And it's going to be typically a polynomial over a polynomial. All right, that's how they're going to be written. And the biggest thing with rational functions, we're going to be graphing them and determining their domains and ranges, so just their x values and their y values. But in order to do that, there's a new word that we're going to learn. Asymptote, okay? And there are there's two different kinds. There is a vertical. Let's start here. Asymptote. And essentially this is going to be a line vertically through your graph that the function comes close to but doesn't touch. Okay? And there's a horizontal again, it's going to be horizontally aligned through the graph that the function comes close to but doesn't quite touch. So if we had a rational function and it was, let's put it out to the side out here, and it was y equals a over x minus b and then plus c. Okay, so that could be a function. Our vertical asymptote is what x can not be. So that's just like our excluded value. Our vertical asymptote is what our excluded value is. So it's, the line is x equals b. Because hoi vux, that is a vertical line when x through the x-axis. You'll see what that looks like in just a second. And then a horizontal asymptote is whatever is this constant. And that line is y equals c. So whatever that number is, that's where it crosses the y-axis. And it's a horizontal line. Okay? So now let's practice with one, finding the asymptotes and graphing it. All right? So if I had the function y equals 5 over x plus 2, okay, the first thing that I need to do is identify the asymptotes, okay? So what can x not be to be the excluded value? The denominator can't be 0. X cannot be negative 2. So our vertical asymptote is x equals negative 2. I know it's what x can't equal, but in this case, that is what it equals, but we understand. All right, and then the horizontal asymptote, remember, it's that constant next to it. There is no constant. So the horizontal asymptote is just 0. Okay? Now let's see what it looks like to then graph it. All right? Just like any other function or line, I'm going to pick values to create a table for some points. I'm going to select points close to this vertical asymptote, okay? Or x values that are close to it. Okay? So let's go from -7, -4, -3, -1. I'm just picking these numbers because it's going to end up having whole and half y values. Okay, it does not matter which ones you pick because there's still going to be points on the line. But obviously I can't pick -2 because it's where the function comes close to touching but doesn't touch. So it cannot be -2. If x was -2, the denominator would be 0 and it would be an undefined line. That defeats the purpose of what we're doing. So I'm going to plug in -7. Okay, so 5 over -5, which was -7 plus 2 is -5, is -1. I'm going to plug in a 4 for x. I'm left with -2.5. Plug in 3, -5. Plug in -1, I have +5. Plug in 0, I have 2.5. And plug in 3. 3 plus 2 is 5. 5 divided by 5 is 1. Okay? So that's how I find my ordered pairs. And then what I'm going to do, and we're just going to just briefly sketch this graph. It does not have to be perfect. Okay? But let's go ahead and make hash marks. Okay? Now, you're going to first look at the asymptotes, and I'm going to quote-unquote graph these. When you're graphing an asymptote, all you do is sketch the line, so like a dotted line, for these lines. If the line is x equals -2, on the x value, or the x axis, I'm going to -2. And I know it's a vertical asymptote. It's a vertical line. Okay? And then I'm going to the horizontal. Well, it's when y is 0, so it's really just straight through here, through the origin. It's really just the x-axis. Okay? Now I'm going to plot the points. I'm going to -7, -1, -4, -2.5. Again, just a rough sketch here. -3, -5. Okay, and it's going to look like this. Okay. Then we're going to keep going. I have 0, 2.5, and 3, 1. Oh, and -1, 5. I missed that one. Okay. And that's my rational function. You see that my function, essentially there are two lines. They come close to the asymptote, but they'll never touch it. Otherwise, it'd just be an undefined line, right? Same with the horizontal. It comes close to that axis, but doesn't touch it both ways. All right? Very good. So the domain, my x values, can be anything greater than -2 or less than -2. All right, good. Let's try another one. Let's say f of x or y equals, it doesn't matter how it's written, it's the same thing. 3 over x minus 1, and then -2. Again, we're going to identify the horizontal and vertical asymptotes. Okay. X cannot be 1, so the asymptote is the line x equals 1. Horizontal, it's what's that constant? Y equals -2. Okay? I'm going to sketch out my table. Again, I want my values to be close to this one, but obviously it can't be 1. So let's say -2, -1, 0, 2, 3, and I think that's good enough. Okay, remember, because it can't be 1. X can't be 1, but can be all those other things. Plug in negative 2 down here. 3 divided by 3 minus 2 is negative 3. Substitute in 1, negative 3.5. Substitute in 0. I'm left with negative 5. Substitute in 2. I'm left with 1. And substitute in 3. I'm left with negative 0.5. Okay? Again, I'm going to just try to briefly sketch this graph. The first thing that I'm going to do is mark my asymptotes. X is, the X is is 1. Okay? And then Y at the horizontal asymptote through the y-axis is negative 2. So something like that. Okay, again, it doesn't have to be perfect. All right, then I'm going to graph negative 2, negative 3. Like that. Negative 1, negative 3.5. 0, negative 5. Something like that. Maybe a little straighter than that. I'm going to 2 and then 1. So this is 1, so 2. So right 2, up 1. Right 3, down 1.5. Okay, good. I want you to try this last one. Let's do f of x equals 2 over x plus 1 and then plus 4. You need the vertical asymptote, the horizontal asymptote. Okay, I want you to do all of that. Set up a table and graph. Okay, the code word for this lesson is Ed Westwick.